Hey guys, Mr. Mises here. Welcome to my video today. Today I'm going to look at inverse trig functions. Now this is going to be a quick video for review for AP Calculus. Now if it goes a little too fast and you want a little bit more background, you can go to, which side am I? Over here. You can go to the video over here, and this link will take you to a video of some more explanation on how we get some of the graphs and how we get some of the range and domain descriptions of inverse trig functions. I go a little more in depth in that. So go check that out if you want a little bit more. Otherwise, let's get going. Let's check this out. Okay, so here we go. We've got some inverse trig function stuff that you need to know. So first thing you need to know here is that the regular trig functions are not one-to-one. So they really don't have inverses, but if we just shrink the domain and we only look at some specific range values, then we can in fact have an inverse function, but it's range restricted. All right, so basically here, the domain for the inverses are -1 to 1. The range values are -π/2 to π/2. So those are the y values. So of course we switch them, and that would be the domain and the range for the inverse function. Okay, so these are the domain and the ranges for our inverse functions now. Remember, we switch them. The range, again, for sine, remember sine goes like this. The range was -1, 1, because it was up here to down here. And then the domain was all real numbers. Well, we got to switch things, and now we have to, man, I can't talk today. I got something in my mouth. We have to restrict the range. So let's take a look at what these graphs look like. Again, you're going to want to make sure you understand and you know these range restrictions for each of these types of graphs. And again, if you want to look at the video that I had before, that I put a link there for, you can take a look at that video. That does have more information on how we remember those range restrictions. So arcsine is going to look like this, just like that. That's it. So -π/2 to π/2 and -1 to 1 in our domain. Arc cosine is going to look like this. Okay. And arctangent is going to have 2 horizontal asymptotes. Yeah, believe it or not, 2 horizontal asymptotes, because it has multiple vertical asymptotes if you think about what the tangent graph looks like. So just one part of that, one piece of that's going to have 2 horizontal asymptotes at π/2 and -π/2. So those are the graphs of the 3 major inverse ones that you're going to need to know, especially when we do integration later on. So here's a geometric representation of the range values that you're going to need to be able to do. Okay, let me get rid of this Facebook thing here. These are the range values that you're going to need to know, so make sure you know those, because when we're solving for arc cosine, arcsine, arctangent, we're going to need to know that we can only look in those parts for the unit circle. Students make 2 major mistakes. If they make mistakes, here are the most common ones. They put the inappropriate range values for their answer, or they put more than the right answer for one range value that you have. Now, for inverse functions, for inverse trig, you only have one answer. You don't have 2 or more answers in 0 to 2 pi. You can only have one answer because of the range restriction. So, for example, arcsine of -1/2. Okay, arcsine of -1/2. That's going to be -1/2 is going to be what angle is going to give me the y value of -1/2. Well, the y value of -1/2 is right here. The only angle that happens at is -π/6. I got to go this way. This is not 7π/6. We can't go all the way around because that's not in the range of arcsine. So there can only be one correct answer for appropriate range values for arcsine, arccosine, arctangent. Okay, so that's one of the biggest mistakes we see. All right, so let's take a look. By the way, this video is not going to have any calculus involved. I'm going to do the calculus in the next video. So this video is just going to have a lot of that review stuff. All right, so let's go ahead and evaluate some of these. The other thing here is that, all right, same idea here. Okay, same idea with that. So let's do a couple of ones. So what's the arctangent of 1? The arctangent of 1 is basically asking for what angle on the unit circle will I get 1 for my tangent? Well, that's only going to happen one place. That's when we get square root of 2 over 2 and square root of 2 over 2, which on the unit circle is right here. And that aligns with the range of arctangent. So the answer for this is pi over 4. Okay, what about the arc cosine of -1? Well, arc cosine -1 is where's the cosine -1? Remembering that cosine has to be between here and here. The only place is right here at pi, so the answer is pi. Where's the arc sine of negative? What's the arc sine of negative? √3 over 2. So arc sine is asking really where's the y value in my unit circle? -√3 over 2. Again, arc sine can only be here and here. My y value is negative, so it's going to be the long angle here, and this angle here is going to be negative pi over 3. Again, we can't say in the unit circle this is not going to be 5 pi over 3. It's going to be negative pi over 3. We got to go down. What about the arc sine of 2? Well, arc sine of 2, we can't have it. If we think about this, where on the unit circle is the y value going to be 2? Well, that's never going to happen. It's not in the range. So this does not exist. All right, non-existent. We don't have that. Can't have that. It's not in the range. All right, so let's use a calculator to evaluate these guys. So what I'm going to do is I'm going to pull up my calculator here. I have a TI Inspire. So here I'm going to have Trig. So I'm going to go to Trig, and this is my inverse sine. It's got a little -1. It's a different way to write it. And we're going to do 0.3. And that's it. Boom, enter, 0.304. Okay, so we're going to write that as 0.305. Bam, that's it. That's all you got to do for that. Let's take a look at the next one. Move this guy over. I got so many tabs. Trig, inverse trig. Now, it's -5/2. If I put this in an Inspire, it's going to just give me the same thing. All right, so what I'm going to want to do here is whenever I have something that's giving me that's a fraction, I don't have a decimal in there, I want it to estimate that, so I'm going to hit Control Enter. -1.19. All right, so I'm going to have -1.190. Remember, we want 3 decimal places, so I got to put the 0 there, even though it rounds to that. So I got to put the 0 there. All right, simple enough. Yes. All right, let's take a look at a few more here. Simplify without a calculator. All right, so just a couple of things here. I don't know if I missed something. Oh, okay. So sine of x and arc sine of x are inverse functions. So when we have sine and arc cosine, they kind of cancel out, but not exactly. So we got to be careful that we're still staying consistent with our range restrictions here. Okay, so let's take a look. Arc sine of √3 over 2. Now, arc sine of √3 over 2 is going to be fine because there's no range restriction on and domain restriction on sine. So these can easily just be simplified to √3 over 2. All right, so whatever is in here. Arctangent and tangent, we're okay with that because the tangent doesn't have any range or domain restrictions. An arctan of 3 can be found. So we're going to say this is 3. Because this is, again, this is in the domain of arctan. All right, so the cosine of pi over 3, is positive, and pi over 3 is within the range restriction of arc cosine. So since they do match up, and I'm okay with my range restriction, I'm going to say this is just pi over 3. Pretty simple, straightforward, guys. However, this one doesn't really work out as easily because 11 pi over 6 is not in my range restriction of arc sine. So I got to do a little bit more work here. I actually have to figure out what the sine of 11 pi over 6 is. So the sine of 11 pi over 6, I use my unit circle to figure this out. All right, 11 pi over 6 is over here. That's going to give me -1/2. And so now that's going to give me negative pi over 6. Again, we can't just say this is 11 pi over 6. Remember, we got to go down for arc sine. So this is the correct answer, is negative pi over 6. Again, we got to be careful with those range restrictions, all right? We really got to be careful with that. All right, this is the last one I'm going to do on this video, and then we'll get to the next video and look at some calculus. So arc sine of x squared minus 3 equals pi over 2. We're going to go ahead and solve for x. In order to do that, we're going to take the sine of both sides. So basically sine and sine. And that's going to give me x squared minus 3 equals the sine of pi over 2. And I know the sine of pi over 2. All right, I know the sine of pi over 2. The sine of pi over 2 is, sine of pi over 2 is 1. Add 3 over, and take the plus or minus square root of both sides. Bada bing, bada boom, done. All right, so that's it for this video, guys. That's just a review, quick review. Next video, I will show you how to do some calculus. So we'll do some derivatives of arc sine, arc cosine, inverse, okay? All right, don't forget to subscribe if you're new. We'll catch you later.